Hello everybody, my name is Rishikesh and today we will compute pulse rate using magnitude response using discrete Fourier transform, and then we will compare with the MATLAB code for finding pulse rate using autocorrelation and magnitude response. So now let us look at what a discrete type Fourier transform is and the formula for discrete Fourier transform. So discrete Fourier transform for signal x of k is x of n, given it is given by x of n is equal to summation of k is equal to 0 to n minus 1 x of k e power minus j 2 pi by n into nk, and this is in the polar form, and then we are converting it. This is in the exponential form. We are expanding this exponential into cos and sine terms. Then the expression becomes summation of k is 0 to n minus 1 x of k cos of 2 pi by n into nk plus j into sine of 2 pi by n in nk. And then when we separate out the cos and sine term, it becomes k summation of k is equal to 0 to n minus 1 x of k cos of 2 pi by n nk plus j into summation of k is equal to 0 to n minus 1 x of k sine of 2 pi by n in nk. This cos summation of the cos terms is will be taken as the real part of the cap of the signal x of capital X of k, and the sine part is taken as the imaginary part of the capital X of k, and this the magnitude response of x of n is equal to sum root over real part square plus imaginary part square. So we will be using this formula in computing the pulse rate in Arduino. Now let us look at the Arduino code for this. So this is the input, the PVG signal that we are taking, and then we are going to pass it to the moving average filters to remove the noises and smoothen the curve. Then this is the code for the real part of the discrete Fourier transform, and this is the code for the imaginary part of the discrete Fourier transform. So you can see here there are cos terms here, so this is the real part, and the sine terms, so these are the imaginary part. And then we will be uh, taking the square root of these square of these two, square root of squares of the real part and the imaginary part. So this is the magnitude response. So now let us plot the magnitude response. So this is the magnitude response. So now from this magnitude response we have to find the highest value or the peak value. From that we can find out the pulse rate. So now we will find out the x coordinate of the peak value, and then we will compute the pulse rate of beats per minute from this formula, where the beats per minute is the max 1 into fs into 60 divided by 75. 75 is the number of samples and fs is of 25. So now let us see what the pulse rate is. Let me comment this part. now let us see what the pulse rate of the PPG signal. So now we have got the pulse rate as 80. So now let us uh, check with MATLAB. Check the pulse rate using MATLAB. So we'll be following the same procedure, passing the PPG signal to into a moving average filter. Then we will find the real part and imaginary part. Then we'll find the magnitude response. Then find the x coordinate of the peak value. From that we will be calculating the pulse rate, and this is through magnitude response, and through autocorrelation we will you'll be using autocorrelation function. So you can see that figure 1 is the magnitude response curve, and the figure 2 is the autocorrelation curve. Then the pulse rate through magnitude response we have got as 80, and pulse rate through autocorrelation we have got as 68.18. So now we have verified our results. That's it from this video. Thank you.